Good morning, all of students. I hope all of us in a good condition. Today, we meet again in Home Learning SMPK Penabur. This is the first chapter at grade 8. This chapter talk about motion. Motion. Branch of physics which learn about motion is mechanics. There are two branches of mechanics. The first is kinematics. Kinematics is branch of mechanics which learn about motion without consider the cause of object motion. The second is dynamics, branch of mechanics which learn about cause of object motion, which is force. Now we will learn about kinematics. While we learn about kinematics, we should know about the definition about position and motion. Now we will see the definition for position first. Position is an object location from reference point. And the second, motion is a changing position toward certain reference. Jadi, posisi adalah lokasi benda atau letak benda dari titik acuan. Sedangkan dikatakan sebuah benda itu bergerak kalau posisinya itu berubah terhadap titik acuan. After this, we will learn about the type of motion in kinematics. The first we call as one-dimensional motion. This is what we call as a linear motion. And the second is two-dimensional motion. In this motion, there are two types of motion. The first we call as circular motion, and the second is parabolic motion. The two-dimensional motion will be learned at senior high school. While learning about linear motion, there are several quantities we should know to learn about motion. The first is distance. The second is displacement. The third is speed. The fourth is velocity. The fifth is acceleration. And the sixth is average velocity. Now we will learn about distance and displacement. Before we make a definition for distance and displacement, first we will see the figure below. In this figure, we see that the man moved from start point until the end. And in this figure, there are two lines. The first is green line or green dashed line, and the second is black arrow. The green line represents distance, and black arrow represents displacement. After we see the figure above, now we can give the definition for distance and displacement. And this is the definition for distance. From the figure, we can say that distance is the length of path which is covered by the object without consider the direction which is it move. And the distance is given by symbol S. Jadi jarak adalah panjang lintasan yang dilalui sebuah benda tanpa mempertimbangkan arah gerak daripada benda tersebut. Jarak ini disimbolkan juga dengan simbol S. And definition for displacement is the shorter path between initial position and final position of the moving object at specific direction. Displacement is given by symbol delta x. That delta x is x2 minus x1. That x1 is initial position, or from the figure we can set as the start point, and x2 is final position. And this is the end position. After we have understand about distance and displacement, now we will learn about speed, velocity, and acceleration. Now we'll learn the definition and the formula for speed, velocity, and acceleration. Speed, symbolized by v, is total distance traveled by object divided by total time taken. Because of that, the speed v is formulated by s per t, and velocity is symbolized by v and given arrow above the letter v. The arrow represents that velocity is a vector. Because velocity is vector, because of that, the velocity has direction. And velocity is displacement of the object divided by the time interval. Okay, velocity is formulated by delta x per t. And the last, acceleration, symbolized by a, is change in velocity divided by the change in time. Because of that, acceleration is formulated by a equals delta v per t. Okay. To understand more about distance, displacement, speed, and velocity, we will see the example 1. First, see the figure below. Andy moved from point A to C through E in 20 seconds. Determine A, distance, B, displacement, C, velocity, D, speed. The distance is shown by blue arrow. In here, we can say that as A CE equals S A to E plus S E to C. So we can say that SAEC equals SAE plus SEC equals 25 meter plus 60 meter equals 85 meters. And for question B, displacement is shown by red arrow. This is suitable for the understanding for displacement that the displacement just depends on initial position at A and final position at C. So delta x AEC equals delta x AE plus delta x EC. Delta x AE equals XE minus XA, and delta x EC equals XC min XE. So delta x AEC equals 30 minus 5 plus minus 30 minus 30. So 25 minus 60 meter. So the answer is minus 35 meter. The meaning of minus is direction of displacement to the left. As we know, displacement is a vector. So we can say displacement is 35 meter to the left. And for the next question, C, velocity. Velocity equals delta x AEC divided by t, time taken. So the velocity become minus 35 meter divided by 20 seconds. So velocity is minus 1.75 meter per second. And for the last question, speed. Speed equals distance divided by time. So we can say that distance speed equals 85 meter divided by 20 seconds. So the answer for the speed is 4.25 meter per second. Now we will see the example 2. Bintang moved 28 meters to the north. After that, she moved 5 meters to the east, and finally she moved 16 meters to the south. If she moves in 20 seconds, determine A. Distance, B. Displacement, C. Velocity, D. Speed. To understand about distance displacement, first we have to draw the path that taken by Bintang. The path is shown by blue arrow, that 28 meters to the north, 5 meters to the east, and 16 meters to the south. So she moved from point O and E and finally to point S. Because of that, the distance equals 28 meters plus 5 meters plus 16 meters. So the distance becomes 49 meters. And for the displacement, because displacement just depend by initial position at point O and final position at point S, so displacement is shown by red arrow. Because of that, the displacement delta x equals square root 5 square plus 12 square. So delta x equals square root 169. So the answer is 13 meters to the northeast. And for the point C, velocity equals delta x divided by time taken. So the velocity becomes 13 meters divided by 20 seconds. So the answer for velocity is 0.65 meter per second. And finally, for the speed v equals distance divided by time taken, or s divided by t. So v equals 49 meters divided by 20 seconds. So the answer for the speed equals 2.45 meter per second. After we have understood about distance, displacement, speed, and velocity, now we will learn about average velocity. This is the last part in this video. Before that, we have to understand in linear motion in one direction, the magnitude of distance is equals with displacement. And we know that velocity is displacement divided by time taken. Because the distance equals with displacement, because of that, average velocity can be understanding as total distance divided by total time taken, because the direction of motion just in one direction. Because of that, average velocity can be formulated with s total per time total. To understand about average velocity, we will see the example below. A car moves with velocity 36 km per hour in 60 minutes. After that, it moved with velocity 108 km per hour in 10 minutes. And finally, it moved 72 km per hour in 1 hour. Determine A. Average velocity of the car. B. Grab average velocity Vt. From the example is given V1 36 km per hour and T1 equals 30 minutes equals half hour, and V2 equals 108 km per hour and T2 equals 10 minutes equals 1 per 6 hour, and for V3 equals 72 km per hour and T3 equals 1 hour. And this example asks average velocity. Because average velocity equals total distance divided by total time, because of that, first we should know the distance 1 until distance 3 first. And here we know that S1, distance 1, equals V1 times time 1 equals 36 km per hour times half hour equals 18 kilometers. And for x2, v2 times t2 equals 108 km per hour times 1 per 6 hours equals 18 kilometers too. And for s3 equals v3 times t3 equals 72 km per hour times 1 hour equals 72 kilometers. And for total distance is s1 plus s2 plus s3 equals 108 kilometers. And after that, we determine total time. That total time equals t1 plus t2 and plus t3 equals 10 per 6 hour. Because of that, average velocity equals total distance s total per total time t total equals 108 km per 10 per 6 hour. So the answer for average velocity is 64.8 km per hour. And for the graph for average velocity is the graph between velocity in kilometer per hour and time in hour. Because the first motion is from A to B with constant velocity 36 km per hour in half hour or 3 per 6 hour, so the graph is a constant line AB with velocity 36 km per hour. And after that, The car moved with velocity 108 km per hour from B to C with constant speed too. So the line is shown by BC because the time just in 1 per 6 hour. So the time interval motion BC between 3 per 6 hour and 4 per 6 hour. And for the final motion from C to D with constant speed 72 km per hour in 1 hour. So the line constant between C and D and the interval time is between 4 per 6 hour to 10 per 6 hour. I think this is the material about distance, displacement, speed, velocity, and average velocity. I hope this material can help all of you to understand about the basic concept about linear motion. And to understand more, please do the exercise at the last page.